Hello students, welcome to the EPG Pathshala. I am Dr. Imtiaz Hassan from Jamia Millia Islamia, a Central University, New Delhi. Today I am going to talk about the module rate zonal separation and isopycnic centrifugation. In this module, we discuss the following things in detail. The basic detail about the gradient centrifugation. In the last module, we given the basic information about the gradient centrifugation, but now we'll give you a detail of the gradient centrifugation. Then centrifugation are basically gradient centrifugation basically classified into two groups. One is the rate zonal centrifugation and another is the isopycnic separation. So we'll give you the brief idea description of the both rate zonal centrifugation separation as well as the isopycnic separation. Then in the fourth section we'll discuss the application of density gradient centrifugation. Then we compare rate zonal centrifugation with respect to the isopycnic separation with the discussion on the advantages and disadvantages of the both methods and the choice when you have to go for the rate zonal centrifugation process or when you go for the isopycnic separation. Then we'll discuss the method for preparation of density gradients, what are the choice of the material, how it will be packed, how to create a proper density gradient. And at the last we will also discuss about the different type of rotor that are used for the density gradient centrifugation in detail. So while discussing all these things, you must be familiar with the rate zonal centrifugation, separation and the isopycnic solution. So let's discuss the principle of density gradient centrifugation, because it is based on the density, and not only the density of the molecule has to be separated, it should be also based on the density of the medium, because the density of medium is very important factor for the separation of the molecule. So when suspension of the particle is centrifuged, the sedimentation rate of the particle is proportional to the force applied, and this is given by a well-known equation that is known as Stokes equation, which states that centrifugal velocity is equals to dA square into rho p minus rho l divided by 18 mu multiplied by g. So V is the sedimentation rate, d is the diameter of the particle, means size of the particle, rho p is the particle density that the particle has to be centrifuged, rho l is the liquid density, means the density of the medium, and mu is the viscosity of the medium, and g is the centrifugal force. So this equation clearly indicates that the sedimentation rate of the particle is proportional to the size. Bigger the size, bigger will be the sedimentation rate. So, and smaller the size, lower the sedimentation rate. So it directly depends upon the size of the particle. Then the sedimentation rate is proportional to the difference in density between the particle to be separated with respect to the density of the medium. So if the density of the medium is more than the density of the particle is more than the medium, then it settle downside. If the density of the medium is less than the density of the if the density of particle is less than the density of medium, then it settle outward side, and if there is no difference in the density of particle, it is settled at a particular position, it is not moved further even after applying the force. Then the sedimentation rate decreases as the viscosity of the medium increases, because the buoyant force is increases, frictional force is increases because of the increase in the viscosity of medium. Therefore the viscosity of medium plays a very important role for the separation of molecule during the differential centrifugation or density gradient centrifugation. And finally the sedimentation rate increases as the centrifugal force increases. So all these parameters must be considered for running the density gradient centrifugation. We will go discuss about the density gradient centrifugation. So the centrifugation of homogeneous sample leads to the physical removal of heavy and large particles from the solution and in the form of pellet to the bottom of the tube. However, in density gradient separation, particles are separated on the basis of their relative density while forming a gradient. The density and the viscosity varies for different molecules, which may form a gradient centrifugation force applied. So gradient centrifugation mainly two types. One is the red zonal centrifugation, and other is the isopycnic solution that separation that we'll discuss later. So you can see here there are three types of if you mix two density the molecules with the two different density, then it form a barrier. Heavier particles settle at the bottom and the lighter particles at the top. In the discontinuation gradient centrifugation, there is a series of gradient one laid over one other, but of the similar types of density fixed at a particular position. However, in the case of continuous gradient, there is a continuous increase of the decrease or increase of the gradient from top to the bottom. So this is describes you that how if you mix the molecules of the different density, there are three possibilities: one forming a density barrier, one overlaid each other, second is the discontinuation, and third is the continuous density gradient. I'll give you the basic idea. I'll show through a diagram that how the particles of the different density are settled and at the different position in a gradient separation. So you can see there are three types of the molecule. One is the least dense, big in size. One is the most dense, it is the smaller in size. So if the molecules are mixed together at the top of the tube and it is the centrifuge for a longer time, once the particle achieves their particular density, it will stop at a particular position. That is the basic factor used for the separation of the particle using the density gradient. The molecules are separated in the density gradient centrifugation, as you are aware with the Stokes equation, that the velocity of the molecule got separated. It depends upon the difference in the density of the medium, like the density of the particle and the density of the medium. So that difference is actually an essential factor to separate out the molecule. For example, if you see that the density of particle is more than the density of liquid, then the velocity must be positive. In the other way, if the density of particle is lower than the density of the liquid, then then the velocity is the negative. And if there is no difference in the density of particle as well as the density of the medium, then the velocity is zero and particle stop at a particular position. So this is the very widely used equation that describes that how the molecules got separated during the differential centrifugation while using density gradient medium. We further describe the same thing in a diagrammatic way. You can see here that the particle of the different density are kept at the top and centrifuge for a longer time. So once it is the centrifuge, you can see in the first figure the particle of the different density, like the lowest density settled at the top and the heaviest density is settled at the bottom. In the second slide, you can see if everything is kept at the bottom but and centrifuge for a longer time, then again because the different particle perceives differential centrifugal force as well as the difference in the medium that made this particle to separate according to their density gradient. And in the third case, you can see if you mix all the particle together in entire the tube, again it is separated because of their density. So when the particle density is less than the density of liquid, the velocity is the negative, and accordingly the molecules even at the bottom, it comes at the top depending upon the difference in the medium, difference in the density of the medium as well as the density of the particle. So these are the actually essential factor for the separation of particle during the density gradient centrifugation. We shall discuss about the size of the different organelles, like the nucleus is ranges from 4 to 12 micron. The plasma membrane sheet is ranges from 3 to 20 micron. Golgi tubule, which is ranges from 1 to 2 micron. Mitochondria is ranging from 0.4 to 2.5 micron. Lysosome and peroxisome is ranges from 0.4 to 0.8 micron. and microsomal vesicle are 0.05 to 0.3 micron. The purpose of showing the size of this organelle is to have the idea that if you take the cell fractions, then these organelles are separated at the different position in a gradient centrifugation because of their difference in their size and difference in their densities, and these are the important factor to collect the different cell organelle using the density gradient centrifugation. Now we discuss about the types of density gradient centrifugation. There are two types of density gradient centrifugation for the two different purposes. First is the zonal or rate zonal centrifugation, that sucrose density gradient medium used for the separation. And the second is the iso density, means isopycnic solution, that is the centrifugation in which sodium chloride density gradient medium used for the centrifugation. So the first we'll discuss about the zonal centrifugation. The size difference between the particle affects the separation along with the density of the particle. So in the rate zonal centrifugation, we are taking size as well as density of particle in the consideration, and they are the two important factor for the separation of the particle. Larger the particle move faster through the density gradient than the small particle, and the density range is chosen so that the density of the particle is greater than the density of the medium at all points during the separation. The run is terminated before the separated zones reach the bottom. So the time is the way also very important factor. If you run, you should avoid the long run as well as the short run. And the tube and their equilibrium position should be indicative of the particular separation of the molecule at the particular position. So once the molecule start traveling from top to the bottom, it will settle as per their the density and their size in the tube. The idea about the zonal centrifugation, here you can see here in the rate zonal centrifugation, the molecules are kept at the top and then the centrifuge for the longer time. You can see the three proteins separate according to their size and shape once it achieves the gradient. So in the rate zonal separation, the size and mass of particle is not important factor, as the density of the particle is important factor for the sedimentation. Figure is showing that the rate zonal separation technique, this type of separation technique used for the fractionation of cellular organelle, separation of protein, etc. The speed at which the component settled is primarily depends on its size and mass instead of density. As the particle moves down through the density medium, zones containing component of the similar size form a band, and the faster sedimenting component moves ahead of the slower ones. All molecules eventually form a pallet if the centrifuge long enough, because the density of the component is larger than the density of the gradient. Give you the idea that the preparation of the density gradient solution for the centrifugation medium, like the density 1, density 2, density 3, density 4 and density 5, and then the density of analyte. So the increasing density are arranged in the tube, and the sample is applied in a thin zone at the top centrifuge tube on a density gradient. Under centrifugal force, the particle will begin to sediment through the gradient and separate zone according to their size, shape and density. So if you run at the insufficient time, the incomplete separation occurs. In the same way, if you run over time, then the co-precipitation of all analytes occurs. So there should be a very critical point to check the time, at what time you run, so appropriately you can separate the sample and take it out. So we'll discuss about the isopycnic centrifugation process. In the isopycnic centrifugation process, the density range of the gradient medium encompasses all densities of the sample particles. Each particle will sediment to an equilibrium position in a gradient where the gradient density is equal to the density of the particle, means the isopycnic position. And this type of separation, the particles are separated solely on the basis of differences in their density irrespective of their sizes. So what people do, a tube is taken and increasing density was created from the lowest to highest side, and then in the tube sample has to be separated, is mixed throughout, and then centrifugation process starts. So while the separation centrifugation process, once the particle starts moving as per the law of Stokes equation, once it reaches their isopycnic position, means the particle with the similar density, then it stops moving because there is no more forces acting on it. There is no, the separation velocity becomes zero. So the particle stops at that position, and that is actually factor taken in account for the separation of particle with the different in their densities in during the isopycnic separation or isopycnic centrifugation process. We give you idea about the isopycnic centrifugation technique. In the isopycnic centrifugation technique, sample are applied throughout the tube and it is mixed in the density gradient medium. After centrifugation, the molecules starts migrate towards their isopycnic density, means achieve their density similar to their own density. Like the high density particle goes towards the bottom, and middle density in the center part, and the low density at the top. So the gradient density has to cover the range of different densities of the analyte. Isopycnic solution separation is also known as equilibrium density centrifugation, and in these gradient, molecules have a density somewhere in between the highest and lowest density of the gradient and begin to move along this gradient, as in the case of zone fraction density gradient. In this type of separation, component of particle density is submerged during centrifugation until a position is reached to a point where the density of the surrounding medium is in equilibrium to the density of the component. Once this quasi-equilibrium is achieved, centrifugation time does not have any influence on the particle migration. You can see here in the picture that the molecules are separated as per once it achieves their own density. Giving the 2D picture of the different cell organelle, how fractionated using the density gradient separation of the isopycnic binding density of the particle. And you can see here at the particle having their own S value, and it is the time to get the separate at the different medium. So you can see here the ribosome at the 100S, and you can see the different particles got separated as per their own S values. The comparison of the two methods. So there is the diagrammatic representation of the rate zonal and isopycnic solution centrifugation. So the binding density of the less dense particle is blue and the binding density of the more dense particle is red. So how these molecules are separated in the case, first you can see here in the red zonal centrifugation and in the isopycnic solution. So during the course of different time, the zone is changes in the case of red zonal centrifugation. However, in the case of isopycnic solution, it is the remaining constant. 17 give you the comparison of the two methods, like the moving zone centrifugation or isopycnic solution. So in the centrifugation term, the lower speed not complete the sedimentation and stop at the particular time. However, in the case of isopycnic solution, completely sediment to where the density equilibrium achieved, and it runs at the high speed instead of the lower speed in the red zonal centrifugation. In both the case, similar density, molecular mass and different molecular mass are separated. It is the red zonal centrifugation used for the separation of nucleic acid, cell organelle, and the isopycnic method is used for the separation of protein density, similar density in different buffer. There are many advantage and disadvantage of these two methods, so it has to be analyzed one by one. Like in the case of red zonal runs are considered over isopycnic run for large particles such as cellular organelle, because the red zonal runs take shorter duration. Duration is important as prolonged particle viability and liability is questionable in this case. The second point is the osmotically active particles centrifugation is usually carried out through red zonal runs in the shallower density gradient in order to prevent damage to the particle. For fragile particle, we have to maintain the particle integrity by reducing hydrodynamic shear during the sedimentation. Therefore, we use red zonal runs, as lower RCF is used in the red zonal run than the isopycnic run. In a red zonal run, the duration of centrifugation is critical than the isopycnic run. A certain amount of the centrifugation is required to achieve isopycnic binding, as if the sample was layered on the top of the gradient. Extending the centrifugation time beyond this does not much alter the result. Isopycnic runs uses a steeper density gradient and more stably support the greater quantity of sample. Hence, the large numbers of particles can be separated by this rate centrifugation. So these are some basic comparison between these two methods. Both the method have their own advantage and disadvantage. So you can choose depending on the molecules of choice you want to separate out. The another comparison of the two methods, like you can see, there is a actual difference in their basic principle, that in the rate zonal centrifugation, the sample are kept at the top and it is separated as per the density, their own density, and as depending upon the variable time. However, in the case of isopycnic centrifugation, molecule mix throughout the solution and then it achieves their density as per the difference in their density medium and the difference of the density and the density of the particle. Molecules are taken are settled in the different in the form of band in the density sodium chloride density gradient, and it can be taken out and their optical density or some parameters should be taken for consideration, that is plotted against the concentration versus the fractions, and that is used for the analysis. So we are discussing about the preparation of density gradient for biological particles. The ideal gradient medium has described as one having the following characteristic feature, like covers a sufficient density range for isopycnic binding for all biological molecules of the interest. It means that the density difference from the top to bottom should be very high, so it can covers the boundary of all density of all the biological molecules which are taken under consideration. It possesses physiological ionic strength and pH, so it should be very compatible with the physiological ionic strength and the pH. It is isoosmotic throughout the gradient. Then the fourth point, it has low viscosity. Fifth point, it should be non-toxic. It should not penetrate biological membrane. Then it will form a self-generated gradient by centrifugation at moderate G forces. It should be compatible with the biological materials. It is easily to remove from the purified materials. Does not affect assay procedure because it should not be acts as either substrate or product, so it will always interfere with the such kind of problem is interfere with the analysis. That's why it should not affect the any assay procedure. And it should not quench the radioactive assay because it will again create a problem during the analysis. That's why it should not absorb light, or it should not absorb any radio. It should not create any problem with the radioactive assay. We give you an account about the different types of the density gradient medium used for the separation of biological molecules, like the polyhydric alcohol, which is the most common example is the sucrose, that is the used for the separation of the cell organelle, membrane vesicle, virus, proteins, ribosomes, and polysomes. The glycerol is another polyhydric alcohol which have 3-hydroxyl group. It is a very water soluble molecule and having the very high density. It can be used for the separation of mammalian cells and the proteins. The sorbitol is another alcohol, polyhydric alcohol, and it is used for the separation of non-mammalian subcellular particles. Another group of molecules can be used for the density gradient media preparation are the polysaccharides such as phycols, polysucrose, and dextrans. These are used for the separation of mammalian cells, sometime in combination with the iodinated density gradient media. Mammalian subcellular particles are not frequent. So these are the application of the phycol and polysucrose. Another inorganic salts are also used for the preparation of density gradient media, and the most common are the cesium chloride, which is used for the separation of DNA, virus, proteins, and the cesium sulfate is used for also for the separation of DNA and RNA. People are using KBr, that is the potassium bromide, also for the separation of plasma lipoprotein. Another type of media is the iodinated gradient media like trizoate. It is mainly component for the commercial lymphocyte isolation media for the separation of lymphocyte molecule from the blood cells. The nicodense or histone dense is used for the separation of mammalian cells, organelle, membrane vesicle, viruses. Iodexanol is another iodinated compound used for the iodinated gradient media for the separation of mammalian cells, organelle, membrane vesicle, viruses, plasma lipoproteins, proteins, DNA. And the last, it is the colloidal silica media such as percol used for the separation of mammalian cells, organelles, membrane vesicles, etc. So this slide gives you the basic idea that what are the different types of gradient media used for the separation of different types of molecules. We describe that what are the different types of rotors used for the gradient separation, because the types of rotor is also very essential factor for the separation of biological molecules. So there are four types of rotor. I'll give you the idea, discuss one by one. First is the angle rotor. So the angle rotor is most commonly used type of rotor in which the tube holes are angled at about 0 to 30 degrees and ideally suited for the pelleting. And it depends on the centrifugation method like the differential pelleting, red zonal and isopycnic. Then second is the neo-angle rotor. Neo-angle rotor tube holes are angled at about 10 degree to combine the features of both the angle and vertical rotors. So the faster separation than that using the normal rotor. Then the vertical rotor, the centrifugation separation is conducted with the centrifuge tube set in the vertical position. In such rotor, liquid column is held parallel to the axis of rotation and the centrifugal force is applied at the right angle to the axis of tube. Because the sedimentation path is short, these rotors permits only short runtime. However, a remarkable resolution is achieved. Vertical tube rotors are best fitted for the isopycnic separation. The advantage and disadvantage of each rotor vary significantly and depends upon the particular application. Then the swinging bucket rotor, it's in this case the centrifuge tube are kept level during the centrifugal separation. Longer sedimentation distance optimize separation accuracy, ideally suited for sucrose density gradient centrifugation. During centrifugation, samples swing outward from the center of the rotation and reaches to the right angle of the axis of rotation. Eventually, the force applied to the sedimenting particle moves along the linear axis of the applied force, and swinging bucket rotor are often used for the sucrose density gradient. So these are the different rotors having their own advantage, disadvantage, and these different types of rotor used for the different types of separation depends upon your choice and depends upon the types of medium, method, etc. So now you all are familiar with the isopycnic method, differential centrifugation process, red zonal centrifugation. Then we discussed about what are the factors affecting the separation of the molecule during both the process, what are the advantage and disadvantage of both the process, what time, which types of method can be preferred over each other. Then what are the materials used for the separation like the sucrose, phycol and etc. Then procedure for the preparation of the density gradient, there are the continuous gradient, then discontinuous gradient. Then what are the factors that affect the separation, like it depends on the mass, it depends on the shape, it depends on the partial specific volume, which determines actually S value. So the separation mainly depends upon the S value, and S value is differed for the different molecules. Then we discuss about the isopycnic centrifugation, again to run to equilibrium, separation that depends on the density or the neutral buoyancy. Then what are the step gradient, what are the continuous gradient, where the cesium chloride is used, what are the advantage of cesium chloride, how the molecules are separated. So now you are familiar with the two types of the density gradient centrifugation, isopycnic as well as red zonal centrifugation, and their basis for the separation, their application, and all detail of these two techniques. Thank you very much.